What is up, YouTube? High Tech Lab here. Going back over this automation control panel, a lot has changed since the previous video on this, as well as I've had quite a few questions on that video that I'm going to answer a bit more in depth in this video. So stay tuned, we're going to go over this. So getting started, this panel is broken into two sections. We have generator control and other control. And I'm actually going to be adding more here in the future. And I'll talk about that here in a minute. So for the generator control, this is pretty similar to the previous video. We have start type, which I've, by the way, applied labels to everything. So start type, right now the automatic start and manual start is off. So if I try starting it, it's gonna blink at me and be like, yo, you gotta tell me what you want, right? So if you put it in manual only, you can hit the green button and set the time. So this right here is 60 minutes. So if I were to hit start, it would start the generator and run it for 60 minutes and then shut it down after. And then in manual auto, I have a Outback Mate 3 over here. And this has the automatic generator control, and that would send a signal to this panel, and in the manual auto mode would start the generator. And when that's the case, this light comes on saying that the automatic start is what's initiating the generator. So I'm going to go ahead and hit the start button, and you'll notice the manual start light came on. Accessory power for the generator came on. It's running the glow plugs right now, and here in a few seconds it'll go into the crank mode and crank the generator over. But right now it's on winter settings, so it's running the glow plugs a little long. So you saw right there, generator crank, so it cranked over. It'll give it some time to warm up, and then apply the, there's a contactor in this cabinet I'll show you here in a second, that then applies the load to the generator. As you can see, the light came on, and this battery charger turned on, and is now beginning to charge the batteries. I'm gonna go ahead and shut this off, and you'll notice, you'll hear a big chunk. That was the system unloading the generator, and then it's giving it a few seconds for cool down. And I don't know if you can hear that generator very well, but there it stopped. One of the other things that happens, I have in this room this vent fan. I believe it's like 1200 CFM, and that's wired in as well to this control panel. So I can hit vent manual start, and it'll start that fan, and this timer is how long it's going to run. So as you can see, it's ticking away at 1 hour, and then you can stop it as well. The other thing that happens is when this generator is running, after about 30 seconds of charging, this will start blinking and the vent fan will come on automatically to make sure any off-gassing from the batteries is relieved. This spa fast heat I'll talk about in a second, but it's a toggle. You can toggle it on or off. And then the diversion generator stop, you need the generator running, so I'll hit start again, and then you can activate this mode once it's gotten up and running. So now that it's started up, it's not fully up and running. I can now press this button and it'll turn on diversion generator stop mode. And what that means is when this Outback charge controller right here, let me turn on the light. When this auxiliary output turns on, it'll send a signal down through the gutter, and this is where I'm going to jump into the panel. If you look in this panel, I have a solid state relay right here, and that's coming off this signal right here from that charge controller and sending across this black and orange wire a signal to my PLC. So things are getting a little noisy in here. I'm going to shut the generator back off, but you can see the vent is turned on automatically, and that light flashes indicating it is automatically turned on. So I'm going to go ahead and stop it, and this will all shut down. So part of this diversion system, this is sending power to the heating element. We have a hot tub spa, so any extra power from the solar, or as well as, I'll show you a little bit more in detail, when the generator's running, it's heating that spa off this system. So we are keeping a spa around 106 to 108 degrees up here, completely off the grid. So that diversion power off, as soon as it sees a signal on here with the generator running, indicating that the batteries are nearing a full charge, it goes into the PLC and initiates like a stop signal and shuts down the generator if you have that mode selected. If you don't have that mode selected, it'll run until either the automatic start signal is gone or until the time runs out. So going on with this solid state relay, I have this down here because it needs to be on a heat sink because of the solid state relays just create heat. But this is also wired up through here. There's wires that come up to these two double pole, double throw relays. These are 30 amp rated, 24 volt DC coil. And one of these, if you look right here, this one has a jumper from side to side. So when that shuts closed, it bypasses this solid state relay for 100% power, because this is pulse width modulated. So it's chopping up the power to only allow a certain percentage of extra power to go to that spa as we have it. But when this contactor closes, in fact, both these contactors close, then it's actually transferring from the inverter, because this is fed from the block inverter. It's transferring to the generator, so it's loading the generator with the spa and bypassing the solid state relay. So it's running full tilt off the generator when it's running. So that's the fast heat mode, is it's using all the power that's available to get as much heat in that spa when it's available. And then when the generator shuts off or fast heat mode is deselected, these open back up. They're actually wired, the coils of these are wired in parallel. So when these open back up, it returns to normal operation. This inverter here is the one that I got from Sigeneer Power. And this one, if you notice, when I turn it on and it powers up, it has these cooling fans on top that run constantly. And these have an idle draw of approximately 180 watts per inverter. And I'm not really a fan of having 360 watts of idle draw. So I tapped into the Cat 5 interface on this inverter here and have a wire running back through that 2-inch conduit up and over across the gutter down, and that comes in right here. That's this wire, and that goes to these two ice cube relays. So the PLC actually has control to turn that inverter off and on. So whenever the generator starts up to charge the batteries, it's powering up that inverter, and this one is charging while this one still remains in inverter mode, and this is powering all the loads constantly. That way you don't have any interruptions whatsoever of the transfer between generator power and inverter power. I have this inverter set in mode 8, which is the mode for the desulfation cycle on this inverter. And I have it set like that because I want this system to be able to bring the batteries up to an appropriate voltage. One of the features that I have, based on the fact that I have control over turning this inverter on and off, is I can monitor through this diversion output when these batteries are getting close to full. So the PLC, when it sees input for that diversion, these two wires right here, it knows those batteries are pretty close to full. So if I'm in fast heat mode, what it'll actually do, so it doesn't overheat those batteries, is it'll actually turn off that battery charger, and I believe it turns it off after they've been at appropriate voltage for 15 minutes. It shuts it down for 10 minutes while the generator is running, and then after 10 minutes turns it back on for 15 minutes when it sees that diversion signal. So when the fast heat mode is off, that's if I want to do any equalizing, it'll keep that inverter on the entire time so I can equalize batteries. That way I can still get as much heat out of the runtime for the spa as I can, but I also can avoid boiling some batteries. These two relays right here control that inverter, one of them for the save mode, one of them for the on mode. It turns into on mode, so when it sees this diversion input, since the diversion power coming off the batteries is not a consistent sine wave, it actually creates some dirty power. So that's why I have the diversion power on the black inverter. No diversion power comes off the blue inverter. because I don't want to contaminate and load up that one inverter. So it's actually turning on that other inverter into the on mode as it is diverting power. And if it stops seeing diversion power, it'll wait 5 minutes and then shut that inverter off to save as much power as possible. But I have it staying on for 5 minutes, that way it doesn't short cycle, so it's turning off on, off on, off on. That wouldn't be good for it. So for those of you wondering how I handle the situation with sending power inconsistently to our spa, I have my 3 conductors, 2 hots and a ground coming into here, into this disconnect with a 20 amp GFI breaker. Actually, it's 2 hots, a neutral, and a ground. My apologies, because the GFI breaker needs neutral. So then it comes through. Actually, this right here, this SO cord goes to our hot tub. That is a number 10 conductor with 6 strands. So I have 2 hots, a neutral, a ground, and 2 more hots. So this breaker right here, this 30 amp breaker, runs the pumps and stuff, and that's the constant power supply. And this breaker here is for the heating element, and that's the one that I'm able to pulse width modulate and send separate power. So then this cord runs across to the spa, and I'll show you where that comes in here shortly. Here is where the power comes into the spa. It's got a nice strain relief. Now I would like for this to be a little bit more low profile, so it's less of a tripping hazard, but this spa is in a temporary location, so over time we'll change it. And then in here there's the control panel. I'm not going to pull this apart and get into so much detail, but I will show you that if we open this up, I know the camera is being a little glitchy, but it is 106 degrees and nice and clean. One of the safety features in this room is smoke detectors. I have one in here, and I have one as well over in this half of the room up there on the wall. And those smoke detectors have an output to link them together, so if one detects smoke, they both detect smoke. But I figured out the signal that they're sending and actually brought that in up here to this solid state relay. If you look, I'm using this green and white wire on the input. Those are tied on to that signal wire, those smoke detectors. So for any reason I have a fault with smoke or anything, it immediately triggers an emergency stop signal, and if the generator's running, it'll shut down the inverter, it'll shut down everything it possibly can to avoid an issue if there is any sort of fire or smoke activity. My plan for the future is to tie into this inverter's Cat 5 port as well, and have similar functionality where if it does detect smoke, it'll shut down all the power on the system. But my only concern is our water pumps here are electric, and I need to get a better system for ensuring that I can still use the water pumps in the event I need to fight a fire without shutting down all the power to the pumps. So ultimately, for the generator control, I come out of the PLC with different outputs, and I'll go over the ladder code here in a minute. I have this contactor which closes whenever the call for accessory power is executed. So in other words, whenever this light comes on, this contactor right here is closing. And then as it goes through its cycle, this contactor will close for the glow plugs, and this one will close for the crank signal. And as soon as power comes back on these two right here, this is two 120 volt ice cube relays. Those send a signal, so I have plus 24 volts coming in here. It goes through the one and then through the other and comes back out this white wire right here and goes to the PLC. So the PLC knows when the generator is actually producing 240 volts, which then executes a line to open this contactor so it doesn't continue to crank. This contactor right here is just closing 24 volts. I have a 120 volt to 24 volt AC transformer up here, and that powers this 60 amp contactor. And this is the main power coming from the generator down here, these 3 wires, and going out and feeding half of this split bus panel. So that feeds this 60 amp generator main in this panel here. One of the big questions I got in my last video is how to go from all these controls to actually integrating into the generator. So I have 4 wires on this relay. Those are the power, accessory, crank, glow plugs. I don't know if I covered them all, but either way, the main wires that run that generator come off this relay here, and they go out and down, out the bottom here, out of the panel, into this gutter, and it comes across the gutter. It's actually 10 wires with all the signal and whatnot, and those come to here. I open this for the demonstration of the video. So I have various different wires in here, and those go up, and there's a stub through the wall, and I'll show you the other side of that now. So here we are outside. This is the 2-inch conduit coming from that gutter I was just showing you, and in there it has some junctions, and the generator controls come out this big fat cord right here with the strain relief, and those come down and go across into the back of the generator with this other strain relief. And that is a number 12 conductor. It has 10 of them in that cord, and it comes into this box here. I'm using 8 of those conductors. I have 4 of them are the generator start signals. 2 of them are the 240 volts going back to make sure that the generator is running. And then I have a positive and negative off the battery because we have this fuel pump over here for our diesel, which comes off that gutter and is powered from the generator's 12-volt battery. Since this generator is in fact a trailer unit, if the generator did need to be moved to a different location, all that would need to be done is this would need to be unscrewed and the 10 terminations would need to be removed. Now the cool part of how I set this up, because all the power comes from the generator, as you start removing all these connections, all of the lines going back to the control panel are de-energized because the power starts at the generator. So you don't need to worry about shorting any of these out, because there is simply all the control panel does is closes connections between these lines. So it's very safe in terms of removing these wires and having them out and about while the generator is not in place. Powering this whole control panel is this Rhino power supply. This is from Automation Direct. It is upside down, but that just had to do with the way the terminals were laid out. That comes out and goes through 2 fuses, one on positive, one on negative, that are 2 amps, and goes from there to this DC distribution area in this location. I already began opening this panel to show you guys, but I just wanted to go over this key switch is a 4-position switch. So you have stop where nothing is connected, you have ignition or accessory power, glow plug power, and then if I were to go one more notch, it would crank. So ultimately, that's where the different connections come in. So if I open this around the back, you'll see, and this generator has had modifications done previously. It has a airflow shutoff in case the engine were to be like a runaway diesel. So it had these 2 wires already in this this plastic loom tube. And I went ahead and fished another 6 wires. So this is the voltage panel meter up here on the top left, and I just tied into the back of that right here to get my voltage sensing for the PLC to know that the generator has started. I then have these 4 wires. One of them is tied onto the so you can see the 4 wires for the key switch come in here. One of them's tied onto the power coming to the switch. One of them's on the accessory line, the other one's the glow plug line, and the other one is crank line. And it's that simple. All I'm doing is using relays to do the same thing somebody twisting the key would do. So if you can have a person twisting a key in a certain sequence, you can have a PLC programmed with that same sequence and end up saving all the struggle, right? One other thing that's temporary is I have right here, just temporarily installed, is a 240 watt DC to DC converter that goes from 24 volts to 12 volts. That's temporary because I have these solar trackers on the roof that are powered from these 2 terminals right here, and that's sending 12 volt power to that tracker. But I recently discovered how I can expand this PLC with a couple of extra modules and build in my own solar tracking system where I can have east and west control, as well as controlling, have like a button that is a flat mode so the panels can go flat for in the event of a windstorm. Ultimately, you're going to see video on that where I rebuild the solar tracker and incorporate it with this PLC. And that's the nice part. This is the Click PLC from Automation Direct. All you need to do to expand it is just pop off these little covers, and it reveals a header where you can just plug on more and more modules. So it's great for someone like me that doesn't know what I want at first, I can just keep adding on and adding on up to 8 modules. So that's why I left space in here for future modules. One other thing to see in here is I have a 24-volt alarm powered by the PLC, and that's in case of an emergency. So if the fire alarm signal comes from the smoke detectors, that will go off. If the generator has an issue starting and doesn't send power, that'll go off. Ultimately, it's just to alert in case something happens. One last feature that I want to show you guys is the system reset. You just hit the system reset button and it completely resets all timers, all states, anything saved in the PLC. It's pretty much, if something goes wrong, if there's an error, it resets that, including the alarm. What I will be doing in the future is removing these 2 AC relays, 120 volt AC relays, and actually adding an AC input module to the PLC, because I want to monitor not only that the generator started, because that's pulled straight off the panel meter in the generator, but I also want to monitor the line side of this contactor as well as the load side to make sure that the contactor is working correctly. And I also want to monitor the 240 volts coming off of the Fox Power inverter, just to ensure that the power is on. Because if the batteries go dead and this goes into a low voltage cutout, I no longer have 120 volts to run the transformer that closes the contactor that applies generator power to the battery chargers. But what I can do, if I have control of the on-off of this inverter, is I can turn it off briefly and turn it back on, and there should be enough charge in the batteries for this to turn on and power up and give enough power to close that contactor, which will then begin charging the batteries. One of the things I would like to add in the future is a small control panel outside. Obviously it would need to be protected from the weather. Not sure the details on that, but I would like to have some sort of alarm that would go off prior to this generator starting, indicating that it's getting ready to start, as well as a key switch to lock out. In the case like I'm changing the oil or something, I would want to be able to lock that out. So there are still some safety precautions that need to be added to the system, but this is I'm still learning and still trying new things, and over time I'll get better and better and make this system more and more powerful. Thank you guys for watching. If you enjoyed this video, be sure to leave a thumbs up, and if you haven't already, subscribe to the channel. I do have plans, and I showed off briefly building a new solar rack because we have these flat panels here. So the plan is to be building a rack that tracks, but I'm going to do it a different design than these racks because we did learn many valuable lessons here. Alrighty guys, thank you for watching. I'll see you in the next video. Have a great day. Bye-bye.